So here we have a problem asking about continuity, right? So it says, determine whether the function is continuous or discontinuous at the x value -1. If it's not continuous, state the type of discontinuity. So there's three types of discontinuity. There's jump, there's infinite, and then there's removable. And then for continuous, there's only one continuous, right? And so the steps are kind of the same for all of them. The very first thing we're going to figure out is the function defined at the x value that you're looking at, right? So without simplifying, without doing anything, just plug in or substitute in -1 and see, do you actually get a value, right? So how do you know if you're going to get a value? Well, if you plug it in and you get a number, then it's defined, right? So the only time that you won't get it to be defined is if you end up with 0 in the denominator after you simplify, right? So here, if I plug it in, so a little mental math, on top we got -1 plus 1, which is 0. And the denominator, 1 squared is 1, minus 3 is -2, -2 plus 2 is 0. So since we get 0 over 0, we are undefined at -1. So we already established that it is discontinuous, right? So now that we know that it's discontinuous, we're going to take it a little step further and figure out, okay, what type of discontinuity is it, right? So the very first thing is we're going to try to find the limit as x approaches -1 of my function. Now, the very first thing I do is to find the limit, we substitute in -1 into my function, right? Which means I'm going to end up with 0 over 0, so that we can't just leave it like that. That tells us, okay, maybe we need to try something, right? Now, when I say try something, there's many things you can try depending on how the function looks like. For us, we should recognize that my original function, f of x, is in the form, or the denominator is in the quadratic form, which means that I can probably factor and see where that takes us, right? So if I rewrite the denominator in factored form, the fact that it's an a value of 1, we can jump straight to our factors, and our factors are going to be x plus 2, x plus 1. And we notice that there's an x plus 1 in the numerator and an x plus 1 in the denominator. Now, we have to be careful because, yes, here they cancel out, but we can't, the x plus 2 is in the denominator, right? So we can't just somehow miraculously bring it to the numerator. We have to keep it in the denominator, so we keep it as 1 over x plus 2. Right, and so I kind of created like a mini function, or in other words, I removed the discontinuity, right? I removed the value that was making it discontinuous. And so I'm going to try to find the limit as x approaches -1 of this new version of that function that I have, right? And so again, how do we check the limit? Well, we plug in the value of -1. If I plug in -1, -1 plus 2 is 1. And so we get 1 over 1 or 1. So we found the limit after we tried something, right? So we found that the limit as x approaches -1 is 1 after we were able to remove the discontinuity. So since we were able to remove the discontinuity, what type of discontinuity do we have? We have removable discontinuity at x equals -1. And then all the work that I did, that should be enough to show why is removable discontinuity. So this second function for continuity, we have a piecewise function, and it's basically asking us the same thing, right? So it's asking us, is this function continuous at the x value -2? If it's not, state the type of discontinuity. So the very first thing we got to figure out, just every step is the same, right? Is the function defined at -2? Now, because we have a piecewise function, notice that the bottom one has the or equal to, which means that -2 is part of the bottom domain. And so we're going to use that expression to figure out what is the function defined at -2. So we plug in -2 for x and we simplify. So -2 minus 5 is -7. So we kind of give ourselves a first check, right? The function is defined, and is defined to be -7. So then it's looking like it can either be continuous or it can be jump discontinuity, right? Because those are the only two that start off with the function being defined and then kind of go on either to be continuous or discontinuous based on the limits. So the second thing I'm going to figure out is what is the limit as x approaches -2? Now, the only reason that I'm going to have to check both left and right is because to the left of -2, I have a different expression, and to the right of -2, I have a separate expression, right? So here I'm going to use f of x. And so if I'm checking the limit from the left side, that means everything that is less than -2, which means I'm going to use this expression here. And so if I plug in -2 minus 5 is -7 again. So the limit as x approaches -2 from the left side, it exists and is -7, correct? So now we got to go through and check, okay, well, that was the limit from the left. What about the limit as x approaches -2 from the right side? Well, from the right side, it says everything that is positive, or everything that is to the right of -2, use this expression here, right? And so we're going to go in and plug in -2. So -2 squared is +4. +4 minus 1 is 3. And so the limit from the limit as x approaches -2 from the right side is 3. But notice how the limit from the left is not equal the limit from the right? These are not the same values. So since they're not the same value, then we can conclude that the overall limit, right? So the limit in general as we approach -2, but from left and right, does not exist, right? Because in order for the limit to exist, both left and right have to approach the same value. So we could prove that it's not continuous because the limit doesn't exist, right? And so since it's not continuous, but the function, since it's defined, but there is no limit, then we can say that we have jump discontinuity at x equals -2. And the reason we knew that it was jump discontinuity is because if you look at both left and right separately, there is a limit, just not a general limit.